allow me to act as your guide on your first steps in your cloud journey using the AWS platform. This course is intended for individuals who seek an overall understanding of the AWS Cloud, independent of specific technical roles. Upon completing this course, you should be able to define what the AWS Cloud is, describe the AWS services with common use cases. Also, you should understand the AWS Cloud architectural principles, the shared model, allowing you to relate them to basic security and compliance aspects of the platform. We will also be covering different pricing models and business value of adopting the AWS platform. I'm going to assume that all of you have some general IT technical as well as business knowledge. This course is broken into 5 sections. In Module 1, I will introduce AWS Cloud concepts, which includes an introduction to the cloud and dive in specifically into the AWS platform. Module 2, we will introduce the AWS core services like Amazon Virtual Private Cloud, or VPC, security groups, Amazon Elastic Compute Cloud, or EC2, Amazon Elastic Block Store, or EBS, Amazon Simple Storage Service, or S3, and AWS Database Solutions. As a start, I will say the AWS service name in full, followed by the acronyms or short forms, to ease you into the world of AWS terms, because after a while, it will feel like an alphabet soup of services. Moving on to Module 3, we will touch on AWS security. Here in AWS, security is job zero, and you will find that security concepts, discussions are embedded in all aspects of your interactions with AWS. Hence, it will be important to introduce to you AWS security. What is this thing called AWS Shared Responsibility Model? How do we manage access to the AWS platform and the AWS security resources? In Module 4, we will introduce the AWS well-architected framework, which serves as a guide how to go about designing your environment on the AWS platform in secure, scalable, highly available, and cost-effective manner. Lastly, in Module 5, we will cover AWS pricing and support. Now, we will be touching on high-level pricing concepts instead of actual dollars and cents of using a particular AWS service, like the Amazon Elastic Cloud Compute or EC2. I much prefer that you head down to the pricing page of the AWS service in question to obtain the most updated information. We will briefly introduce you to the TCO calculator and the AWS support plans. As a wrap-up, we will touch on your next steps in your learning journey as you adapt the AWS platform for your organization. All right, without further ado, let's jump into the first module. If you complete watching all the 5 modules, you will receive a certificate of attendance. Please look out for it after 1 week. Let's jump into Module 1, Cloud Concepts. Let's quickly define cloud computing. Cloud computing refers to the on-demand delivery of IT resources and applications via the internet with a pay-as-you-go pricing model. When you are using AWS, you are paying for the time that you are using the resources. For example, if you are running a Linux virtual machine for 3 hours and 40 minutes, you are only paying 3 hours and 40 minutes usage. Hence, another common term used to describe such on-demand delivery of IT resources is utility computing, as pricing model is conceptually similar to how you are being charged for using electricity or water in your home. Before cloud computing, you have to provision capacity based on making an educated guess of what your maximum peaks is. If you didn't meet your projected maximum peaks, you would be paying for expensive resources that would stay idle. Conversely, If you underestimate your actual maximum peaks, you have insufficient capacity to meet your needs. Mind you, this is not taking into account the overheads of real estate, power, and cooling associated with running your own data center. With AWS, you are provided a simple way to access servers, databases, storage, and higher-level application components over the internet. These resources or services can be initiated within seconds without you having to do any physical rack and stack. Any of these services is one click or an API call away. Not only can you initiate these IT resources within seconds, you can treat these as temporary and disposable resources, deprovisioning them when you do not require them, freeing you from the inflexibility and constraints of a fixed and finite IT structure. By harnessing the power of AWS Cloud, your approach to change management, testing, reliability, and capacity planning is more agile and efficient. Once you have created your new AWS account via aws.amazon.com, you can sign into the AWS Management Console by this interface. You can sign in with root credentials. However, it is a security best practice to create IAM users and sign in as an IAM user together with the associated password. Once signed in, you are presented with this interface. You can explore the available AWS services, use our Solutions Builder options to quickly get started with AWS, try out our helpful tutorials and videos, investigate our helpful tips, and explore other topics all via a single click. You can also provide us with your feedback on the platform, change the console display language, read our privacy policy, and our terms of use. We offer multiple methods for you to locate our services. You can view recently visited services, such as the VPC service. But remember, you can always return home by clicking the cube. There's also a handy service drop-down menu offering access to all services, either by alphabetical order or by groupings of related services. You can access your account and billing information or sign out of the console from this menu. You can use the region selection menu to put your focus in the AWS region that you wish to work within for region-scoped services. The support menu provides to the AWS Support Center our public forums, our very comprehensive documentations, and information about AWS training and certification offerings. On the menu bar of the Management Console, you'll also find a handy pin tool that lets you drag and drop icons for your frequently used services onto the menu bar. You can reorder these icons to suit your own preferences. Click the pin again to return to normal operations. You can also remove icons if no longer required. Having set up the icons for your frequently used services, they are now only ever a click away. For each service interface, the left side typically presents a navigation menu of options. Having selected an option, you will now see a list pane for objects at the top and a details pane at the bottom, displaying details of the selected items in the list above. The interface changes according to the service that you're working with. There are controls for you to arrange the list and details pane as required. The details for the selected object are typically accessible by a number of tabs. Remember to return to the starting or home screen, just click the cube icon, which is always at the top left-hand corner. The number one reason organizations are moving to the cloud is increased agility. There are three factors that influence agility: speed, experimentation, culture of innovation. Let's take a closer look at how these factors enable organizations to be more agile by harnessing the power of cloud computing. With AWS facilities all over the world, this can offer you global reach within minutes While it is costly to put your data centers where your customers are, well, with AWS, you can get the benefits without having to make the huge initial investment. In cloud computing, new resources are only a click away, which means you reduce the time it takes to make those resources available to your developers from weeks to just minutes, resulting in a dramatic increase in agility for your organization. Another agility benefit of cloud computing is being able to experiment more often. AWS enables operations as code in the cloud and the ability to safely experiment, develop operational procedures, and practice failure. For example, with AWS, you can spin up servers in minutes for experimenting, return or repurpose servers for other experiments. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations. Using services such as AWS CloudFormation enables you to have consistent, templated dev, test, and production environments with increasing levels of operational control. Access to low-cost resources reduces risks and encourages frequent experiments. This is great for IT because it leads to discovery of new configurations and innovations. In order to understand how AWS utilizes the agility of cloud computing, we have to look at the AWS infrastructure that supports elasticity, scalability, and reliability of cloud computing resources. Here are some examples. Elasticity in regards to elastic web scale computing, scalability in regards to scaling your fleet up or down depending on needs, reliability in regards to utilizing a highly reliable environment that AWS offers. Let's review the AWS global infrastructure, which can be broken down into 3 topics: regions, availability zones or AZs, edge locations. Those orange circles you see on the world map are AWS regions distributed across the globe, and the number within are the number of availability zones or AZs in that region. But what is a region? A region is a geographic area that contains 2 or more availability zones or AZs. Regions are separate entities from one another, and resources in one region are not automatically replicated to other regions. While building and choosing your custom services and features, you have the opportunity to choose in what geographical region your information will be stored. When doing so, it is important to consider which region will help you optimize latency while minimizing costs and adhering to whatever regulatory requirements you may have. Let's dive deeper here on this point. If you are leveraging cloud computing services, you can easily deploy your application in multiple regions. For instance, you can have an application in a region nearest to your headquarters in Singapore. Let's say your largest customer base is located in Melbourne, Australia. With a few clicks, you can easily deploy in the Sydney region to provide a better experience for your customers while minimizing latency and increasing agility for your organizations. All of this within minutes and with minimal cost. Given that the AWS platform has more than 105 services as of August 2018, ranging from compute, storage, security, to Internet of Things, IoT, artificial intelligence, AI, how would you choose a region if latency is not an issue? Well, head down to the AWS region table page that lists down the various AWS services available in the regions around the globe. Here, you can sort through Americas, Europe, Middle East, Africa, and finally, Asia Pacific. Notice that the table is broken down even more into specific locations and what services are currently offered there. Now, let's talk about AZs. AZs are a collection of data centers within a specific region. Each are isolated from one another, but yet they are connected together by a fast, low latency link. So, what exactly is the benefit of having the AZs isolated but also connected? When common points of failure occur, it does not affect all of your AZs because they are isolated. How are they exactly isolated? Each AZ is a physically distinct, independent infrastructure. They are also physically and logically separated. Each AZ has their own discrete, uninterrupted power supply, on-site backup generators, cooling equipment, networking, and connectivity. They are all supplied via different grids from independent utility companies and connected through multiple Tier 1 transit providers. However, all of those details are transparent to you. From your perspective, a single AZ is equivalent to an on-premise data center. Why is this important? By following the AWS best practice and provision your applications and data across 2 or more AZs, you are in effect replicating the operational principles of deploying workloads across 2 fault-isolated data centers in an on-premises design. To deliver content to end users with lower latency, as of August 2018, AWS uses a global network of 114 points of presence, 103 edge locations, and 11 regional edge caches in 56 cities across 24 countries. Regional edge caches are used to optimize caching on the edge locations so that users have a higher probability of accessing information there instead of querying the origin servers, resulting in high latency. All of this optimization is transparent to users. Amazon CloudFront is a content delivery network, or CDN, service used to deliver content to your customers. Requests for content are automatically routed to the nearest edge location so that the content is delivered faster to the end users. Utilizing the global network of edge locations and regions, you have access to quicker content delivery. Edge locations are typically located in highly populated areas similar to regions and AZs. In addition to CloudFront, a number of AWS services leverages on the edge locations. For example, Amazon Route 53 is a highly available and scalable domain name system, or DNS web service. AWS Shield, which is a managed DDoS protection service. And lastly, AWS WAF, which is a managed web application firewall service. Apart from increasing speed and reducing latency, one of the most important roles of an edge location is offering security at the edge before reaching your data hosted in regions. Using AWS, customers develop high-performing and reliable solutions to address most business needs. Whether you are offering media services to customers around the world or managing medical devices for a highly decentralized workforce, AWS gives us the tools to implement solutions quickly and with limited friction. Reliability at AWS is defined as the ability of a system to recover from infrastructure or service failures. It also focuses on the ability to dynamically acquire compute resources to meet demand and mitigate disruptions. In order to achieve reliability, your architecture and system must have well-planned foundations in demand and also detect failure and automatically heal itself. Elasticity is the power to scale computing resources up or down easily, while only paying for actual resources used. Whether you need one virtual server or thousands, whether you need computing resources for a few hours or 24/7, AWS provides an elastic infrastructure to meet your needs. The elastic nature of AWS also accommodates AWS offers customers innovative new services and products to utilize for their needs. With AWS, you can easily deploy your system in multiple regions around the world while providing a lower latency and better experience for your customers at minimal cost. Thanks to the efficiencies of scale that AWS enjoys, you can consistently use innovative services and cutting-edge technology without having to go through multiple procurement cycles and expensive evaluations. AWS provides capabilities to support virtually any workload. This level of innovation gives customers continued access to the latest technology. One of the key benefits for AWS customers is the ability to use services at your own pace. Using AWS provides, customers can grow, shrink, and adapt their consumptions of services to meet seasonal requirements. AWS also delivers a scalable cloud computing platform designed for high availability and dependability, providing the tools that enable you to run a wide range of applications. Using AWS tools like auto-scaling and elastic load balancing, your application can scale up or down based on demand. Backed by AWS massive infrastructure, you have access to compute and storage resources when you need them. We have come to the end of Module 1. Test your knowledge with the following questions. Hello everyone. Thanks for joining me at the AWSome Day Online Conference. I'm Quek Meng-Chong, and I am a Senior Technical Trainer with AWS. Hello everyone. Thanks for joining me at the AWSome Day Online Conference. I'm Quek Meng-Chong, and I am a Senior Technical Trainer with AWS. I've been with AWS for a few years and have had the opportunity to assist many of our customers in their cloud journey. Allow me to act as your guide on your first steps in your cloud journey using the AWS platform. This course is intended for individuals who seek an overall understanding of the AWS Cloud, independent of specific technical roles. Upon completing this course, you should be able to define what the AWS Cloud is, describe the AWS services with common use cases. Also, you should understand the AWS Cloud architectural principles, the shared responsibility model, allowing you to relate them to basic security and compliance aspects of the platform. We will also be covering different pricing models. Then, do check out the Elastic Load Balancing product page for more details and side-by-side comparisons. Application Load Balancer can be used in many scenarios. One is the ability to use containers to host your microservices and route to those applications from a single load balancer. Application Load Balancer allows you to route different requests to the same instance, but defer the path based on the pod. If you have different containers listening on various pods, you can set up routing rules to distribute traffic to only the desired backend application. Here, you can see how the Application Load Balancer routes and organizes backend targets. While configuring a listeners for the load balancer, you create rules to direct how the request received by the load balancer will be routed to the backend targets. To register those targets to the load balancer and configure the health check the load balancer will use for the targets, you create target groups. Targets can also be members of multiple target groups. Depending on how your backend is designed, targets can be either EC2 instances or containers. NLB is optimized to handle sudden and volatile traffic patterns while using a single static IP address per AZ. Because it can handle millions of requests per second while maintaining ultra-low latencies, it is ideal for the applications that require extreme performance. And to complete the compute conversation, we will now touch on autoscaling. Autoscaling assists you with designing the desired number of Amazon EC2 instances you want to handle the load for your application. Using autoscaling removes the guesswork of how many EC2 instances you must have at a point in time to meet your workload requirements. When you run your applications on EC2 instances, it is critical to monitor the performance of your workload using Amazon CloudWatch. CloudWatch by itself, however, will not add or remove EC2 instances. This is where autoscaling comes into the picture. With Amazon EC2 autoscaling, you can maintain the health and availability of your fleet. Also dynamically scale your EC2 instances to meet demands during spikes and lulls. Let's look at an example workload. You could use CloudWatch to measure EC2 resource requirements over a standard week. Note that the resource requirements vary, with Wednesday requiring the most capacity and Saturday the least. If you allocate enough EC2 capacity to handle your highest demand time, in this case Wednesday, it means that you are over-provisioning most of the week. This is not a cost-optimized option. On the other hand, you could allocate fewer EC2 instances, thus reducing costs. This could mean that you are under capacity on certain days. And if you don't solve your capacity problem, your application could underperform or potentially even time out for your user. Autoscaling allows you to add or remove EC2 instances based on conditions that you specify. Autoscaling is especially powerful in environments with fluctuating performance requirements. This allows you to maintain performance and minimize costs. So autoscaling really answers two critical questions. How can I make sure that my workload has enough EC2 resources to meet fluctuating performance requirements? And how can EC2 resource provisioning occur on demand? Autoscaling matches up with two AWS best practices. Make your environment scalable and automate as much as possible. Let's take a look at autoscaling a little closer. So what exactly is meant by scaling? The first thing you have to do is define the conditions for scaling out and scaling in. Autoscaling can automatically adjust the number of EC2 instances running workload based on either conditions that you defined, for example, CPU utilization over 80%, or a schedule. If autoscaling adds more instances, this is termed scaling out. This is represented by the middle diagram where the ELB is load balancing 3 EC2 instances. The instance highlighted by the green box represents the third instance added to the autoscaling group compared to the base configuration. As autoscaling terminates instances, this is an example of scaling in. This is represented by the diagram on the right, where one of the instances has been terminated, resulting in only 2 instances in the autoscaling group. Remember that you have control as to what initiates these events. So, How do you automatically scale? There are 3 components required for auto-scaling. First, you create a launch configuration. Second, you create an auto-scaling group. And finally, you define at least one auto-scaling policy. Let's take a closer look at what each of these components do. A launch configuration defines what will be launched by auto-scaling. Think of all the things that you would specify when you launch an EC2 instance from the console. These include which Amazon machine image to use, what instance type, security groups, or roles to apply to the instance. What is an auto-scaling group? This is about defining where the deployment takes place and some bounds for the deployment. This is where you define which VPC and subnets to deploy instances, which load balancer to interact with. You also specify the boundaries for a group. If you set a minimum of 2 and your server count goes below 2, another instance will be launched to replace it. If you set the maximum of 8, there will never be more than 8 instances in your group. The desired capacity is the number of EC2 instances that you want now. Lastly, what is an auto-scaling policy? This is about specifying when to launch or terminate EC2 instances. You can schedule auto-scaling every Thursday at 3 p.m., for example, or create conditions, if met, to trigger adding or removing instances. Condition-based policies make your auto-scaling dynamic and can meet fluctuating requirements. It is best practice to create at least one auto-scaling policy to specify when to scale out, and at least one policy to specify when to scale in. So how does dynamic auto-scaling work? One common configuration is to create CloudWatch alarms based on performance information from your EC2 instances or a load balancer. As a performance threshold is breached, a CloudWatch alarm triggers an auto-scaling event which either scales out or scales in EC2 instances in the environment. Briefly, CloudWatch is a monitoring service used to collect performance statistics like EC2 instance CPU utilization and turn them into matrices to be monitored. For example, if you are monitoring CPU utilization of an EC2 instance using CloudWatch and have an alarm set to trigger if the utilization is set above 60%. If the alarm is triggered, CloudWatch will execute the auto-scaling policy to add one or more EC2 instances to the auto-scaling group. Auto-scaling will inform ELB to register the new EC2 instance and start sending requests to it. The same principle applies for scaling in. The first part of the alarm is a condition with a specific threshold. In this case, CPU utilization is greater than 80%. Note there is also a time period specified that you can control. This means you could be specifying that the alarm will fire up if CPU utilization is over 80% for 5 consecutive minutes. The time period is critical because you don't want auto-scaling to trigger new instances because your processor spiked for 30 seconds. The second part of the alarm is the action to perform after the alarm is triggered. With auto-scaling, the action could be to add or remove instances. So in this example, if the CPU is over 80% for one consecutive period, 5 minutes by default, auto-scaling will add 2 new instances to the auto-scaling group. When you add more instances, the CPU utilization should go down. You should set another CloudWatch alarm to define a threshold as to when instances should be terminated from the auto-scaling group. As an example, as CPU utilization goes below 20% for more than 5 consecutive minutes, terminate one instance. The beauty of it all is that auto-scaling can manage your workload dynamically, so you do not have to focus on it. Let's summarize what you have learned. Autoscaling allows you to add or remove EC2 instances based on conditions that you specify. Autoscaling is especially powerful in environments with fluctuating performance requirements. This allows you to maintain performance and minimize costs. Best of all, this process can scale in or out EC2 instances in the middle of the night while you are sleeping. The three core components you must have are a launch configuration, what you like to deploy, an autoscaling group, where you would like to deploy, and an autoscaling policy, when you would like to deploy. Remember, every AWS service that you learned about is another tool to build solutions. Now, into one of my favorite topics, storage. And first up is Amazon Elastic Block Store, or EBS. Think of Amazon Elastic Block Store, or EBS volumes, as an actual hard drive that can be used as a storage unit for your Amazon EC2 instance. So whenever you think you must have disk space for your instances running on AWS, you can use them. These volumes can be hard drive or SSD devices, and you pay as you use them. So whenever you don't need a volume anymore, you can just delete it. Amazon Elastic Block Store, or EBS volumes, are designed for being durable and available. This means that the data in a volume is automatically replicated across multiple servers running in the AZ. I made a comparison about EBS volumes and physical devices like hard drives or SSDs for the ease of understanding. But it's actually more durable than that because of the block-level replication. While creating an EBS volume, you can select the type of storage that best fits your needs. You can choose between magnetic or SSD based on your performance and price requirements. It is all about choosing the right tool for the right job. So for example, if you're running a database instance, you can configure the database to use a secondary volume using SSD for data, which may perform faster than the volume assigned to the operating system. Or you can assign a magnetic volume for the logs, because magnetic is cheaper. To provide an even higher level of data durability, Amazon EBS gives you the ability to create point-in-time snapshots of your volumes, and AWS allows you to recreate a new volume from a snapshot at any time. Share or even copy snapshots to different AWS regions for even greater disaster recovery protection. You can, for example, share your snapshots from the Singapore to the Tokyo region. You can also have encrypted EBS volumes at no additional costs. The encryption occurs on the EC2 side, so the data moving between the EC2 instance and the EBS volume inside AWS data centers will be encrypted in transit. When your company grows, the amount of data stored on your EBS volumes will probably also grow. EBS volumes have the ability to increase capacity and change to different types, meaning that you can change from hard drive to SSD or increase from a 50 gigabyte volume to a 16 terabyte volume. And this resizing operation can be done on the fly without having to stop the instances. And that's it. In summary, we have reviewed what EBS volumes are and its various characteristics. We will next take a look at one of our oldest AWS service, Amazon Simple Storage Service, or S3. Amazon Simple Storage Service, or S3, is a fully managed storage service that provides a simple API for storing and retrieving data. You don't have to manage any infrastructure yourself and can put as many objects into S3 as you want. S3 holds trillions of objects and regularly peaks at millions of requests per second, such as images, videos, or server logs. S3 supports objects as large as 5 terabytes in size. You could even store database snapshots as objects. Amazon S3 also provides low latency access to the data over the internet by HTTP or HTTPS, so you can retrieve data anytime, anywhere. You can also access S3 privately through a S3 bucket policies, and even per-object access control lists. By default, none of your data is shared publicly. You can also encrypt your data in transit and choose to enable server-side encryption on your objects. Let's take a file that needs to be stored in S3, such as a welcome video. First, you have to create a bucket whose name must be globally unique in Amazon S3 service. This is because the bucket name is used to form a unique URL that you can use to access the bucket. When you want to put this welcome video into the bucket as an object, you can do so by uploading it into the bucket via the management console with a click of a button. The name of the file, welcome.mp4, is now the key that you will reference as part of the URL to access the actual object in the S3 bucket. The sample URL has been color-coded to highlight where the bucket name and key come together to form a unique URL used to access the video. You can access S3 by the management console, AWS CLI, or AWS SDK. Additionally, you can also access the data in your bucket directly via REST endpoints. These support HTTP or HTTPS access. This flexibility to store virtually unlimited amount of data and access that data from anywhere makes the S3 service suitable for a wide range of scenarios. As a location for any application data, S3 buckets provide that shared location for storing objects that any instance of your application can access, including applications on EC2 instances or on-premises servers. This can be useful for user-generated media files, server logs, or other files your application needs to store in a common location. Also, because the content can be fetched directly over the web, you can offload serving that content from your application and allow clients to directly fetch the data themselves from S3. For static web hosting, S3 buckets can serve up the static content of your website, including HTML, CSS, JavaScript, and other files. S3 is designed for 11 nines of durability, which makes it a good candidate to store backups of your data. For even greater availability and disaster recovery capability, S3 can even be configured to support cross-region replication such that data put into an S3 bucket in one region can be automatically replicated to another S3 region. The scalable storage and performance of S3 make it a great candidate for staging or long-term storage of data you plan to analyze using a variety of big data tools. In summary, we have taken a quick look at Amazon S3, touched on some of its characteristics like high durability, accessibility, security controls, and some common use cases. Right, so now we're going to log in using a demo user called S3 Demo into the AWS Management Console. Once in, we're going to click on the S3 icon in the navigation bar at the top of the page, which will drop us into the Amazon S3 console. Now I'm going to create a bucket using S3 Demo as the name, and I'm going to drop it in the Singapore region.
leaving everything else as default. When I try to click the create button, it gives me an error message saying that the bucket name already exists. Now, it really doesn't matter which region I select now, because the bucket name must be unique across the AWS infrastructure. So I'm going to change the name to something else. And I'm going to still select the Singapore region. As you can see. Next, I'm going to upload an object into this demo bucket. Clicking on Upload, Add Files, and I'll select a file randomly from my laptop. And this happens to be an image. And I'll click on Upload, and it now appears in my bucket. Selecting the Tiger JPEG, I can see that this particular object has a unique URL which I can select and try to access it. But as you can see, I receive an access denied error message because by default, all buckets are not public. I can very easily make this particular image publicly accessible by clicking the Make Public button. And refreshing that same tab, you will now see the image I have uploaded. That ends the very short and simple demonstration of creating S3 bucket and uploading an object. We shift gears now and look at different AWS database services. Coming up is Amazon Relational Database Service, or RDS. Let's first take a look at the challenges of running a standalone relational database. As you run your own database, you are responsible for several administrative tasks like server maintenance, OS and software installation, as well as patching, backups, ensuring high availability, scalability. All these tasks take resources away from other items on your to-do list and requires expertise in several areas. To address the challenges that come with running your own relational database, AWS provides a service that sets up, operates, and scales the relational database without any ongoing administration. Amazon Relational Database Service, or RDS, provides cost-efficient and resizable capacity while automating time-consuming administrative tasks like the ones we have previously covered. Amazon Relational Database Service, or RDS, frees you to focus on your application so you can give them the performance, high availability, security, and compatibility they must have. With Amazon RDS, your primary focus becomes your data and optimizing your application. Amazon RDS manages operating system installation and patching, database software installation and patching, automatic backups, and high availability. Scaling resources, managing power and servers, and performing maintenance is also covered by AWS. In short, all of the undifferentiated heavy lifting is offloaded to managed Amazon RDS service, reducing your operational workload and the costs associated with your relational database. Now let's go through a brief overview of the service and a few potential use cases. The basic building block of Amazon RDS is the database instance. A database instance is an isolated database environment that can contain multiple user-created databases and can be accessed by using the same tools and applications that you use with a standalone database server. The resources found in the database instance can be determined by its database instance class, and the type of storage is dictated by the type of drives. Database instances and storage differ in performance characteristics and price, allowing you to tailor your performance and costs to the needs of your database. When you choose to create a database instance, you first have to specify which database engine to run. Amazon RDS currently supports 6 database engines: MySQL, Amazon Aurora, Microsoft SQL Server, PostgreSQL, MariaDB, and Oracle. You deploy an Amazon RDS instance in a VPC of your choice, giving you control over your virtual networking environment. One of the most powerful features of Amazon RDS is the ability to configure your database instance for high availability with a multi-AZ deployment. After configuration, Amazon RDS automatically generates a standby copy of the database instance in another AZ within the same Amazon VPC. After seeding the database copy, transactions are synchronously replicated to the standby copy. Running a database instance with multi-AZ can enhance availability during planned system maintenance and help protect your databases against database instance failure and AZ disruptions. If the master database instance fails, Amazon RDS automatically brings the standby database instance online as the new master. Due to the synchronous replication, there should be no data loss. As the applications refer the database by name using RDS DNS endpoint, you don't have to change anything in your application code to use the standby copy for failover. Amazon RDS also supports the creation of read replicas for MySQL, MariaDB, PostgreSQL, and Amazon Aurora. Updates made to the source database instance are asynchronously copied to the read replica instance. You can reduce the load on your source database instance by routing read queries from applications to the read replica. Using read replicas, you can also scale out beyond the capacity constraints of a single database instance for read-heavy database workloads. Read replicas can also be promoted to become the master database instance. But because of the asynchronous replication, this requires manual action. Read replicas can be created in a different region as a new master database. This feature can help satisfy disaster recovery requirements or cutting down on latency by directing reads to a read replica closer to the user. Amazon RDS supports the most demanding database applications. You can choose between 2 SSD-backed storage options, one optimized for high-performance OLTP applications, and the other for cost-effective general-purpose use. With Amazon RDS, you can scale your database compute and storage resources with no downtime and use the AWS Management Console, the Amazon RDS command line, or simple API calls to manage the service. Amazon RDS runs on the same highly reliable infrastructure used by other AWS services. It also lets you run your database instances in your VPC, which provides you with control and security. Now let's take a look at a managed NoSQL database service, Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL non-relational database service. AWS manages all of the underlying data infrastructure for this service and redundantly stores data across multiple facilities within a region as part of the fault-tolerant architecture. With DynamoDB, you can create tables and items. You can add items to a table. For the DB administrators out there, an item in a DynamoDB table is similar to a row in the RDBMS table. the DynamoDB service automatically partitions your table and has table storage to meet the workload requirements with no practical limit on the number of items you can store in a table. Some customers have production tables that contain billions of items. One of the benefits of a NoSQL database is that items in the same table may have different attributes. This gives you the flexibility to add attributes as your application evolves. You can have newer format items stored side by side with older format items in the same table without having to perform schema migrations. Again, for the DB administrators out there, attributes in DynamoDB are similar to columns in an RDBMS table. As your application becomes more popular and as users continue to interact with it, the DynamoDB table can grow with your application needs. All of the data in DynamoDB is stored on solid-state drives, and a simple query language allows for consistent, low-latency query performance. In addition to scaling storage, DynamoDB also allows you to provision the amount of read or write throughput you have to have for your table. When the number of application users grow, DynamoDB tables can be manually scaled to handle the increased number of reads and writes requests with manual provisioning. Alternatively, you can enable auto-scaling so DynamoDB monitors the load on the table and automatically increases or decreases the provision throughput. Some additional key differentiating features include global tables that enables you to automatically replicate across your choice of AWS regions, encryption at rest, and item TTL. The ability to see your tables in terms of both storage and provision throughput makes Amazon DynamoDB a good fit for structured data from the web, mobile, and Internet of Things applications. For instance, you may have a large number of clients continuously generating data and making large numbers of requests per second. In this case, the throughput scaling of DynamoDB allows consistent performance for your clients. DynamoDB is also used in latency-sensitive applications. The predictable query performance, even in large tables, makes it useful for cases where variable latency could cause significant impact to the user experience or to business goals such as ad tech or gaming. Table data is partitioned and indexed by primary key. There are two ways of retrieving data from a DynamoDB table. The first method is the query operation that takes advantage of the partitioning to effectively locate items by using the primary key. The second method is via a scan, which will allow you to locate items in the table by matching conditions on non-key attributes. The second method gives you flexibility to locate items by other attributes. However, the operation is less efficient as DynamoDB will scan through all the items in the table to find the ones that match your criteria. To take full advantage of query operations and DynamoDB, it's important to think about the key you use to uniquely identify items in a DynamoDB table. You can set up a simple primary key based on a single attribute of the data values with a uniform distribution, such as the GUID or other random identifiers. For example, if you were to model a table with products, you could use some attributes, such as the product ID, that would be the table on the left. Alternatively, you can specify a compound key, which would be composed of a partition key and a sort key. That would be the table on the right. In this example, if I was to have a table on songs, I might use the combination of song title and singer to uniquely identify table items. In summary, Amazon DynamoDB is a managed NoSQL database service which can be used as a data store for applications which need to scale to store large amounts of data, support high request volume, and require low latency query performance. We have come to the end of Module 2. Test your knowledge with the following questions. Now that we have done a walkthrough of the AWS core services on the AWS platform, it is time to take a look at security. In this module, we will introduce AWS security, explain what is the AWS shared responsibility model, how to control and manage access to AWS services in your account, and some of the security resources and features available on the AWS platform. Introduction to AWS security. AWS delivers a scalable cloud computing platform designed for high availability and dependability, providing the tools that enable you to run a wide range of applications, helping to protect the confidentiality, integrity, and availability of your systems and data is of the utmost importance to AWS, as is maintaining customer trust and confidence. This module is intended to introduce AWS approach to security, including the controls in the AWS environment and some of the products and features that AWS makes available to customers to meet their security objectives. All AWS customers benefit from a data center and network architecture built to satisfy the requirements of our most security-sensitive customers. This means that you get a resilient infrastructure designed for high security without the capital outlay and operational overhead of a traditional data center. The AWS infrastructure puts strong safeguards in place to help protect customer privacy. AWS innovates rapidly at scale, continually incorporating customer feedback into AWS services. This continual improvement benefits all customers because AWS solutions improve over time, including constantly evolving core security services such as identity and access management, logging and monitoring, encryption and key management, network segmentation, and standard DDoS protection at little to no additional cost. You also get advanced security services invented by engineers with deep insight into global security trends, allowing your team to proactively address emerging risks in real time while paying for only what you use, all at a lower cost. This means you can choose the security that meets your needs as you grow, without upfront expenses and with much lower operational overhead when compared to managing your own infrastructure. A properly secured environment helps to create a compliant environment. When you migrate your regulated workloads to AWS Cloud, you can achieve a high level of security at scale by using our many governance-enabling features. Cloud-based governance offers a lower cost of entry, easier operations, and improved agility by providing more oversight, security control, and central automation. AWS and its partners offer a wide range of tools and features to help you to meet your security objectives. These tools mirror the familiar controls you deploy within your own on-premises environments. AWS provides security-specific tools and features across network security, configuration management, access control, and data security. In addition, AWS provides monitoring and logging tools, which gives full visibility into what is happening in your environment. AWS provides several security capabilities and services to increase privacy and control network access. These include built-in firewalls that allow you to create private networks within AWS and control network access to your instances and subnets. For example, the security groups that we have covered in the earlier part of this course. Encryption in transit with TLS across all services. Connectivity options that enable dedicated connections from your office or on-premises environment to AWS, which are called AWS Direct Connect. DDoS mitigation technologies as part of your content delivery strategy. AWS offers a range of tools to allow you to move fast while still enabling you to design your cloud resources to comply with organizational standards and best practices. These include deployment tools to manage the creation and decommissioning of AWS resources according to organization standards. Inventory and configuration management tools to identify AWS resources and then track and manage changes to those resources over time. Template definition and management tools to create standard, pre-configured, hardened virtual machines for EC2 instances. AWS offers you the ability to add a layer of security to your data at rest in the cloud, providing scalable and efficient encryption features. Data encryption capabilities are available in AWS storage and database services such as Amazon EBS, Amazon S3, Amazon Glacier, Amazon RDS, and Amazon DynamoDB. Flexible key management options allow you to choose whether to have AWS manage the encryption keys or for customers to maintain complete control over their keys. AWS Key Management Service, or KMS, is a managed service that makes it easy for you to create and control the encryption keys used to encrypt your data. It is integrated with AWS CloudTrail to provide you with logs of all key usage to help meet your regulatory and compliance needs. Dedicated hardware-based cryptographic key storage options are available for customers to help satisfy compliance requirements. AWS Cloud HSM is a cloud-based hardware security module that enables you to easily generate and use your own encryption keys on the AWS Cloud, where you, the customer, owns the root of trust. In addition, AWS provides APIs for you to integrate encryption and data protection with any of the services you develop or deploy in an AWS environment. AWS offers you the ability to add a layer of security to your data at rest in the cloud, providing scalable and efficient encryption features. AWS Identity and Access Management, IAM, is a role-based access control service that manages administrative access to the AWS services available in AWS. Multi-factor authentication, MFA, adds extra security because it requires users to type a unique authentication code from an approved authentication device. With Federation, you can use single sign-on, SSO, to access your AWS accounts using credentials from your corporate directory. Amazon Cognito lets you easily add user sign-up and authentication to your mobile and web apps. It enables authentication of users through an external identity provider and provide temporary secure credentials to access your app's backend resources. AWS SSO is a service that makes it easy to centrally manage SSO access to multiple AWS accounts and business applications. With AWS SSO, you can manage SSO access and user permissions to all of your accounts centrally. AWS provides tools and features that enable you to see what's happening in your AWS environment. These include AWS CloudTrail that provides visibility into API calls, including who, what, when, and from where calls were made. Amazon CloudWatch Logs for log aggregation and options, streamlining investigations and compliance reporting. Amazon CloudWatch Alarms to send notifications when specific events occur. These tools and features give you the visibility you must have to spot issues before they impact the business and allow you to improve security posture and reduce the risk profile of your environment. What if you want to make use of the same tools you have been using in your on-premises environment on the AWS platform? The AWS Marketplace offers hundreds of industry-leading partner products that are equivalent, identical to, or integrate with existing controls in your on-premises environments, including anti-malware web application firewalls and intrusion protection. These products complement the tools and features offered by AWS to enable you to deploy a comprehensive security architecture and a more seamless experience across your cloud and on-premises environments. What is the AWS Shared Responsibility Model? After the customer starts using the AWS platform, AWS shares the responsibility of securing the data in AWS with its customers. This concept is known as the AWS Shared Responsibility Model. Let's take a look at what AWS is responsible for and what the customer is responsible for in this model. AWS is responsible for what is known as security of the cloud. What does that mean? Under the shared responsibility model, AWS operates, manages, and controls the components from the host operating system and the virtualization layer down to the physical security of the facilities in which the services operate. It means that AWS is responsible for protecting the global infrastructure that runs all of the services offered in the AWS cloud, which include regions, AZs, and edge locations. Protecting this infrastructure is AWS' #1 priority, and while you can't visit AWS data centers or offices to see this protection firsthand, AWS provides several reports from third-party auditors who have verified our compliance with a variety of computer security standards and regulations. Note that in addition to protecting this global infrastructure, AWS is responsible for the security configurations of its products that are considered foundational or managed services, which include compute, storage, database, and networking. Examples of these types of services include Amazon DynamoDB, Amazon RDS, Amazon Redshift, Amazon Elastic MapReduce, Amazon Workspaces. While the cloud infrastructure is secured and maintained by AWS, customers are responsible for security of everything they put in the cloud. When using AWS services, customers maintain complete control over their content and are responsible for managing critical content security requirements, including what content they choose to store on AWS, which AWS services are used with the content, in what country that content is stored, the format and structure of that content, and whether it is masked, anonymized, or encrypted, who has access to that content, and how those access rights are granted, managed, and revoked, who has administrative rights to the AWS services available in the AWS account. Customers get to retain control of what security they choose to implement to protect their own data, platform, identity and access management, applications and operating systems. That includes patching their guest OS and applications. This basically means that the shared responsibility model changes depending on the AWS service the customer uses. One of the key AWS security services is Identity and Access Management, which is the next service we are looking at. AWS IAM is a service that helps you securely control access to AWS resources for your users. You use AWS IAM to control who can use your AWS resources, this is known as authentication, and how they can use resources, known as authorization. AWS IAM allows you to manage access to compute, storage, database, and application services in the AWS Cloud. In short, this is the role-based access control or RBAC mechanism to manage access on the AWS platform. Think of the access control concepts you are already familiar with, such as users. Think of these as your end users. Groups, think of these as a collection of users by job function. Permissions, which can be applied to users or groups. And roles, think of these as trusted entities. That's exactly what AWS IAM uses, which makes it so powerful. Using AWS IAM, you can create and manage AWS users and groups and use permissions to allow and deny the access to AWS resources. Let's take a closer look at IAM functionality. AWS IAM allows you to, firstly, manage AWS IAM users and their access. You can create users in the AWS IAM, assign individual security credentials, in other words, access keys, passwords, and multi-factor authentication devices, or request temporary security credentials to provide users access to AWS resources and services. You can manage permissions to control which operations a user can perform. Next, manage AWS IAM roles and their permissions. You can create roles in AWS IAM and manage permissions to control which operations can be performed by the entity or AWS service that assumes the role. Finally, manage federated users and their permissions. You can enable identity federation to allow existing identities like users, groups, and roles from your corporate directory to access the AWS Management Console, call AWS APIs, and access resources without the need to create an IAM user for each identity. When you first create an AWS account, you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. This identity is called the AWS account root user and is accessed by signing in with the email address and password that you used to create the account. Because you can't restrict permissions for root user credentials, it is recommended that you delete your root user access keys. If you require administrator-level permissions, create an IAM user, grant that user full administrator access, and then use those credentials to interact with AWS. If you need to modify or revoke your permissions, you can delete or modify the policies that are associated with that IAM user. When adding users, you get to select how users will access AWS. There are two different types of access you can assign users: programmatic access and AWS Management Console access. Programmatic access enables an access key ID and secret access key for the AWS API, CLI, SDK, and other development tools. The other option is to give AWS Management Console access to users, which allows them to sign in to the AWS Management Console. The AWS Management Console provides a simple web interface for AWS. You can log in using your AWS account name and password. If you have enabled AWS multi-factor authentication, you will be prompted for your device's authentication code. After a user has been authenticated, they then have to be authorized to access an AWS service. To assign permission to a user, group, or role, you have to create a policy, which is a document that explicitly lists permissions. It is important to note, as depicted in the diagram, that one policy can be assigned to an IAM user, IAM group, and IAM roles. On the AWS Management Console, we click on IAM to the left of your screen. On the AWS IAM console, we have a few options to choose from. Let's click on Policies. Here, you see the AWS Managed Policies. Let us create a policy using the AWS Policy Generator wizard. We start with the Allow option and choose Amazon S3 under AWS Services. Under Actions, we could allow all list operations. Rather than selecting all the list operations, let us select one for now and update the policy later. Under Amazon Resource Name, we use the wildcard character. On the Amazon S3 console, we have a bucket which contains a folder labeled Public. The folder contains a picture, and the same picture is also stored on the root of the bucket. Let's create a second statement in AWS IAM for Amazon S3. Under Action, let's choose the GET object operation to permit download. For Amazon Resource Name, or ARN, let's follow the documentation to learn more about the structure. The ARN always starts with ARN, followed by AWS, and a service in use. In our example, we will use S3, followed by the bucket name, /folder, and /star to indicate all objects under the policy. Now let's create a statement for Amazon EC2. Under Actions, we will select all Describe and Get actions, along with the options to start and stop instances. Finally, under ARN, let's use star to indicate all instances and click on Next Step. Let's give the policy a name, a description, and let's replace S3:list bucket with S3:list star, which indicates all list operations. We then validate the policy and create the policy. The policy can be listed using the Customer Managed filter. Let's create a group called Team1 and attach the policy we created earlier. After we create the group, we proceed to create users. Because the user 1 will only need console access, we select the appropriate option. The user is provided with the password and now can be prompted to enter a new password if needed. We now add the user to the group, making sure they have the right permissions. Login details can also be emailed to the user. For this example, we will copy the login URL and use another browser to simulate the new user login. Notice the AWS account is specified and the user only enters the login credentials. After logging in, let's go to the Amazon EC2 console and then to the Instance option to find the list of instances. If the user tries to terminate an instance, they get an unauthorized error message. However, if the user tries to start an instance, as per the policy, it should be successful. Similarly, a stop operation should also be permitted. Let's now move to the Amazon S3 console. As per the policy, the user should be permitted to list all the buckets and their contents. But any option to download objects should fail unless it is a public folder in the demo bucket. Any option to download an object in the bucket also fails unless it is the public folder. As expected, the picture was successfully downloaded. Now that you have seen how AWS IAM works, let's walk through some of the best practices of AWS IAM. Delete your AWS root account access keys because they provide unrestricted access to your AWS resources. Instead, use IAM user access keys or temporary security credentials. Activate multi-factor authentication, or MFA, on your AWS root account to add another layer of protection to keep your account secure. Create IAM users and give them only the permissions they have to have. Do not use your AWS root account for day-to-day interaction with AWS because the root account provides unrestricted access to your AWS resources. Use IAM groups to assign permissions to your IAM users to simplify managing and auditing permissions in your account. Apply an IAM password policy to require your IAM users to create strong passwords and to rotate their passwords regularly. Use roles for applications that run on Amazon EC2 instances instead of storing credentials in the instances. Delegate by using roles instead of by sharing credentials. For example, this can be used to temporarily grant access to an IAM user from AWS account A to AWS account B without having to create another IAM user in account B. Rotate credentials regularly. Remove unnecessary users and credentials. Use policy conditions for extra security. For example, you can restrict certain actions that modify or delete existing settings to only when the login is via MFA. Lastly, monitor activity in your AWS account using AWS CloudTrail. We have come to the end of Module 3. Test your knowledge with the following questions. Welcome to Module 4, where we will look at some architectural concepts that will guide you in your designing of AWS environment. The well-architected framework has been developed to help cloud architects build the most secure, high-performing, resilient, and efficient infrastructure possible for their applications. This framework provides a consistent approach for customers and partners to evaluate architectures and provide guidance to help implement designs that will scale with your application needs over time. The AWS well-architected framework helps customers assess and improve their own architectures, all while getting a better understanding of how their design decisions can impact their business. AWS experts have developed several questions to help customers analyze and critically think about their architecture. The framework helps you to determine whether your infrastructure follows best practices. With that, AWS has developed a guide to help you with the design of your architecture from 5 different perspectives or pillars. The pillars are security, reliability, performance efficiency, cost optimization, and operational excellence. Let's go into more details. The security pillar encompasses the ability to protect your information, systems, and assets. It accomplishes this while delivering business value through risk assessments and mitigating strategies. To dive a little deeper here, cloud security is comprised of 5 areas. Let's briefly look into each area. Identity and access management, which is critical to make sure that only authorized and authenticated users can access your resources and only in the manner you intend. There are also detective controls, which can be used to identify a potential security incident by considering some approaches such as capturing, analyzing logs, and integrating auditing controls. Infrastructure protection. This is designed to ensure systems and services within your architecture are protected against unintended and unauthorized access. For instance, the user can create network boundaries, hardening and patching OSs, users, keys, access levels, and application firewalls or gateways. With data protection, there are numerous approaches and methods to consider. Some of them include data classification, encryption, protecting data at rest and in transit, data backup, replication and recovery when needed. Incident response. Even with all the preventive and detective measures, organizations should still create an incident response process to respond to and mitigate any potential security incidents. Incident response is designed to keep your architecture updated to accommodate a timely investigation and recovery. When you are architecting, it's important to consider specific design principles to help you strengthen your security. Apply security at all layers. You want to have multiple layers of defense by securing your infrastructure everywhere and at every layer. In a physical data center, security is typically considered only at the perimeter. With AWS, you can implement security at the perimeter and within and between your resources. This is designed to assist with your individual environment and components that they are secured from each other as well. Next, enable traceability through logging and auditing all actions or changes to your environment. Another useful design principle is the principle of least privilege. Make sure that authorization within your environment is adequate and that you are implementing strong logical access controls to your AWS resources, granting minimal privileges for business requirements. Next, focus on securing your system. With the AWS Shared Responsibility model, you can focus clearly on securing your application, data, and operating systems, while AWS provides secure infrastructure and services. Finally, automate security best practices. Software-based security mechanisms improve your ability to securely scale more rapidly and cost-effectively. For example, create and save a patched, hardened image of a virtual server so that when you need an image, you can use that image automatically to create a new instance. Another best practice is to automate the response to both routine and anonymous security events. The focus with the reliability pillar is that it encompasses the ability of a system to recover from infrastructure or service failures. It also focuses on the ability to dynamically acquire compute resources to meet demand and mitigate disruptions. The bottom line is that reliability is there to assist in the ability. Reliability in the cloud is composed of three areas: foundations, change management, failure management. In order to achieve reliability, your architecture and system must have well-planned foundation in place that can handle changes in demand or with requirements, and also detect failure and automatically self-heal. Before architecting any sort of structure, it is critical to look at the foundation before construction. Similarly, in the cloud, before architecting any system, foundational requirements that influence reliability should be in place. With change management, it is really important to fully understand and be aware of how change can affect your system. If you plan proactively and monitor your systems, you can accommodate and adjust to change quickly and reliably. To really make sure your architecture is reliable, it is key to anticipate, be aware, respond, and prevent failures from happening. In a cloud environment, you can take advantage of automation with monitoring, replace systems in your environment, and later troubleshoot failed systems all at low cost, and all while still being reliable. The design principles that can increase reliability include testing recovery procedures. In the cloud, users have the ability to test how systems fail and can validate their recovery procedures. Users can simulate and expose different failures and then rectify before a real failure occurs. Automatically recover from failure. In AWS, users can trigger automated responses when thresholds are breached. This makes it possible to anticipate and remediate failures before they occur. Scale horizontally to increase aggregate system availability. When you have one large resource, it is beneficial to replace that large resource with multiple small resources to reduce the impact of a single point of failure on the overall system. Scale horizontally and distribute requests among the multiple small resources. Stop guessing capacity. In the cloud environment, you have the ability to monitor demand and systems utilization and automate the addition or removal of resources. This is designed to make sure you have the optimal level to satisfy your demand without over or under provisioning. Manage change in automation. Changes to your architectures and infrastructure should be made using automation. With this, you only need to manage change through your automation, not every single system or resource. Now let's look at the performance efficiency pillar. The four pieces that make up performance efficiency in the cloud include selection, review, monitoring, trade-offs. Let's dive deeper into each area. With selection, it is important to choose the best solution that will optimize your architecture. However, these solutions vary based on the kind of workload you have. With AWS, resources are virtualized and allow you to customize your solutions in many different types and configurations. With Review, you can continuously innovate your solutions and take advantage of the newer technologies and approaches that become available. Any of these newly released services or features can improve the performance efficiency of your architecture. With regards to monitoring, after you have implemented your architecture, you will need to monitor performance to verify that you can remediate any issues before customers are affected and aware of them. With AWS, you can use automation and monitor your architecture with tools such as Amazon CloudWatch, Amazon Simple Queue Service, and AWS Lambda. Finally, there are trade-offs. An example of a trade-off is trading consistency, durability, and space versus time or latency to deliver higher performance. Now let's look at the design principles that can help you achieve performance efficiency. First, democratize advanced technologies. Technologies that are difficult to implement can become simpler to consume by pushing that knowledge and complexity into the cloud vendor's domain. Instead of having your IT team learn how to host and run the new technology, they can consume it as a service. Then you have going global in minutes. With AWS, you can easily deploy your systems in multiple regions around the world while providing a lower latency and better experience for your customers at minimal cost. The next design principle that can help you achieve performance efficiency is to use a serverless architecture. In the cloud, you remove the need to run and maintain traditional server for compute activities. This also removes the operational burden and can lower transactional costs. Another design principle is to experiment more often. With virtualization, you can quickly carry out testing to enhance efficiency. Finally, there's mathematical sympathy. This principle has suggestions to use the technology approach that best aligns to what you are trying to achieve. Essentially, use the tool or service that best suits your needs. Our next pillar is the cost optimization pillar, which includes the continual process of refinement and improvement of a system throughout its entire life cycle. This pillar encompasses the idea that you can build and operate cost-aware systems and maximize its return on investment. The four areas that make up the cost optimization pillar include cost-effective resources, matching supply with demand, expenditure awareness, and finally, optimizing over time. A fully cost-optimized system will use all resources it has to achieve the best outcome at the lowest possible price point, all while still meeting your functional requirements. Making sure that your systems are using the appropriate services, resources, and configurations is one of the key parts to cost savings. As a user, you want to focus on the details such as provisioning, sizing, purchasing options, and other specifics to design the best architecture for your needs. Another component to cost optimization is matching your supply with your demand. With AWS Cloud, you can leverage the elasticity of the cloud architecture to meet demands as they change. You can auto-scale and be notified by other services to adjust your supply due to demand changes. Then, we have expenditure awareness. Being fully aware and cognizant of what spending and cost drivers are happening with your business is critical. Having the ability to see, understand, and break down the current costs, predict future costs, and plan accordingly only enhances the cost optimization of your architecture in the cloud. Finally, in AWS, we can optimize over time with all of the tools and different approaches. You can measure, monitor, and improve your architecture from the data you collected in the AWS platform. Adopt a consumption model. With a consumption model, you pay only for the computing resources you use and then increase or decrease depending on business requirements, essentially trading CapEx for OpEx. The next principle is to measure overall efficiency. It is important to measure the business output of the systems and costs associated with delivering it. Then take this measurement to understand how gains are made from increasing output and reducing costs. Stop spending money on data center operations. With AWS, you no longer have to do the heavy lifting of racking, stacking, and power servers. We take that burden so that you can focus on your customers and businesses and projects instead of the IT infrastructure. Next, analyze and attribute expenditure. With the cloud, it is so much simpler and easier to accurately identify the usage and cost of systems. Customers can measure their return on investment, which provides them the opportunity to optimize resources and reduce costs. Finally, we suggest customers to use managed services to reduce the cost of ownership. The cloud has provided many managed services to remove the operational burden of maintaining servers for tasks such as sending emails or managing databases. And since this is all done on a cloud scale, they can offer a lower cost per transaction or service. The operational excellence pillar focuses on running and monitoring systems to deliver business value and continually improving processes and procedures. Key topics include managing and automating changes, responding to events, and defining standards to successfully manage daily operations. In summary, here are the 5 pillars that make up the AWS well-architected framework. We have come to the end of Module 4. Please test your knowledge with these questions. How you consume AWS services can be greatly influenced by understanding how pricing on the AWS platform is done. And as you shift more and more production workload on AWS, you need to know which support level is suitable for your needs. Briefly, these are 4 areas we will touch on in this section: fundamentals of pricing, pricing details, overview of the total cost of ownership calculator, overview of AWS support plans. First up, fundamentals of pricing. AWS offers a range of cloud computing services. For each service, you pay for exactly the amount of resources you actually need. This utility-style pricing model includes pay-as-you-go, pay less when you reserve, pay even less per unit by using more, pay even less as AWS grows. Let's take a closer look at these core concepts of pricing. Unless you are in the business of building data centers, you have probably spent too much time and money doing just that. With AWS, you no longer need to dedicate valuable resources to build costly infrastructure, including purchasing servers, software licenses, or leasing facilities. With AWS, you can replace large upfront expenses with lower variable costs and pay only for what you use and for as long as you need it. All AWS services are available on demand and require no long-term contracts and have no complex licensing dependencies. Pay-as-you-go pricing allows you to easily adapt to changing business needs without overcommitting budgets and improving your responsiveness to changes. With a pay-as-you-go model, you can adapt your business depending on need and not on forecasts, reducing the risk of over-provisioning or missing capacity. By paying for services on a need basis, you can redirect your focus to innovation and invention, reducing procurement complexities and enabling your business to be fully elastic. Pay less when you reserve. For certain services like Amazon EC2 and Amazon RDS, you can invest in reserved capacity. With reserved instances, you can save up to 75% over equivalent on-demand capacity. Reserved instances are available in 3 options: all upfront, partial upfront, or no upfront payments. When you buy reserved instances, the larger the upfront payment, the greater the discount. To maximize your savings, you can pay all upfront and receive the largest discount. Partial upfront RIs offer lower discounts but give you the option to spend less upfront. Lastly, you can choose to spend nothing upfront and receive a smaller discount by allowing you to create more capital to spend in other projects. By using reserved capacity, your organization can minimize risks, more predictably manage budgets, and comply with policies that require longer-term commitments. With AWS, you can get volume-based discounts and realize important savings as your usage increases. For services such as S3 and data transfer out from EC2, pricing is tiered, meaning the more you use, the less you pay per gigabyte. In addition, data transfer in has no charge. As a result, as your AWS usage needs increase, you benefit from the economies of scale that allow you to increase adoption and keep costs under control. As your organization evolves, AWS also gives you options to acquire services that help you address your business needs. For example, AWS Storage Service Portfolio offers options to help you lower pricing based on how frequently you access data and the performance you need to retrieve it. To optimize your savings, choose the right combinations of storage solutions that help you reduce costs while preserving performance, security, and durability. AWS is constantly focused on reducing data center hardware costs, improving operational efficiencies, lowering power consumption, and generally lowering the cost of doing business. These optimizations and AWS's substantial and growing economies of scale result in passing savings back to you in the form of lower pricing. Since 2006, AWS has lowered pricing more than 60 times. AWS realizes that every customer has different needs. If none of AWS's pricing models work for your project, custom pricing is available for high-volume projects with unique requirements. To help new AWS customers get started in the cloud, AWS offers a free usage tier. If you are a new AWS customer, you can run an Amazon EC2 T2 micro instance for a year while also leveraging a free usage tier for Amazon S3, Amazon Elastic Block Store, Elastic Load Balancing, AWS Data Transfer, and other AWS services. AWS also offers a variety of services for no additional charge. Amazon VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in the virtual network that you define. AWS Elastic Beanstalk is an even easier way for you to quickly deploy and manage applications in the AWS cloud. AWS CloudFormation gives developers and system administrators an easy way to create a collection of related AWS resources and provision them in an orderly and predictable fashion. AWS IAM controls your users' access to AWS services and resources. Auto-scaling automatically adds or removes Amazon EC2 instances according to the conditions you define. With auto-scaling, the number of Amazon EC2 instances you are using increases seamlessly during demand spikes to maintain performance and decreases automatically during demand lulls to minimize costs. Moreover, you can consolidate all your accounts using consolidated billing and get tiering benefits. Is there a way to estimate the cost savings from using AWS versus on-premises environment? The TCO calculator is a tool that has been developed to help you estimate cost savings when using AWS, use detailed sets of reports that can be used in executive presentations, and modify assumptions that best meet your needs. In addition, some benefits of the calculator include the ability of weighing the financial considerations of owning and operating a data center versus using a cloud infrastructure. Also, the TCO calculator explains assumptions and the methodology behind the calculations. So, go take a look. You can launch the TCO calculator through https://awstcocalculator.com. We're going to introduce you to the AWS TCO calculator. As a start, take a look at the URL which you can access this particular tool from the internet. This tool has a basic as well as an advanced option. We're going to stick with the basic option for now. You can select the currency from a list you see in front of you, and I'm going to select the Singapore dollar. You can compare against on-premises or co-location. In our case, we will select on-premises. And in my region of choice, the Singapore region. And I'm going to be comparing against a general workload. I'll put in some fictitious app name, TCO demo, put 2 virtual machines in my comparison, each with 2 CPU cores and 32 gigs worth of memory. For the hypervisor, notice that I have a list which I can select from: VMware, KVM Zen, Hyper-V. As for the guest OS, Linux. Next up, I will specify 100 terabytes worth of raw storage capacity for my SAN storage. And with that, click on Calculate TCO. And now we have the results of the comparison between on-premises versus AWS. And as you can see here, you can save quite a bit of money over a 3-year period. We do a side-by-side comparison between on-premises and AWS. Your cost is color-coded for server, storage, network, and IT labor. And we have a table on the right that gives you the actual numbers over a 3-year period. Some environment details, again, you will notice that we do a side-by-side comparison for on-premises versus AWS. In this case, we're looking at the compute resource, and I'm selecting the M4 2x large, which is the closest fit per the configuration I keyed in earlier on. And I'm going to be using the 3-year partial upfront reserve instance pricing. The table below, EC2 instance matching criteria, will start to make a lot more sense when I change the tool to take into account advanced requirements, whereby I'm going to optimize versus different criteria like CPU, RAM, storage I/O. Further down the list, I have a cost breakdown for compute, again, on-premises versus AWS, storage, and networking. Now notice for the AWS side of things, it's 0 because the AWS VPC service is offered at no charge to our customers. Now by clicking on the Calculations tab, we now have an even more detailed breakdown of server cost. Again, on the left-hand side is the on-premises cost versus what you do spend on the AWS side of things on the right. And we go into a lot more details, like things like server maintenance cost, the racks going to be used in your on-premises environment, rack infrastructure costs. We've included virtualization software costs because of the option that we have selected earlier, which is VMware. Now on the right-hand side, we have a lot more details breaking down the EC2 costs over a 3-year period. But now you have 2 numbers to compare against: on-demand versus reserve instances. And for reserve instances, we're using the 3-year partial upfront cost. Notice that we also include the AWS business support for these EC2 instances as well. Further down, we are also looking at on-premises storage costs versus that of AWS, and as well as the AWS business support costs for EBS volumes. Now notice that we also have included the backup cost comparison between on-premises and AWS. In the case of AWS, we're looking at the snapshot as well as the incremental cost as you add more snapshots for backup purposes. And here you see the networking costs on on-premises environment. However, to complete the picture, we also include the cost breakdown for AWS support as well. Now, we can look at how we go about making those comparisons by selecting the Methodology tab. Under the Methodology section, we're looking at the acquisition costs and operational costs on on-premises environment, where we compare server, storage, network, and IT cost. Now, because some of you are actually using co-location environments, the cost structure is somewhat different, and hence that comparison you see. Finally, we have a comparison of AWS overheads side by side with on-premises environment. Right, this table you see in front of you, while we do include the AWS support costs, but that also includes services. And finally, as you can see here, we have a table that compares what you get by moving your workloads on AWS versus getting hardware on an on-premises environment, which includes things like virtualization software, which is part of our service offering, but that's additional when you have to purchase it on-premises environment. Now, this table here shows you the TCO calculation if we're comparing databases on-premises or co-location environments versus managing your own database running on EC2 instances, and finally versus running RDS, which is a managed service. If you have plans to move your Microsoft SharePoint workload on AWS, what you see here is the
SharePoint architecture, which would be relevant had you selected a SharePoint workload as the workload of comparison at the start of this calculation. However, this is not complete if you do not know what are the assumptions made for cost comparison for on-premises, co-locations versus AWS. So in this list, we also include information like server costs from some of the well-known server vendors. We also include the host configurations, like, for example, the number of CPU cores and system memory. We also include software as well as storage assumptions. Network is not an afterthought. You definitely have to include that. What is sometimes forgotten is power, cooling, and IT costs that's associated with managing an on-premises environment. Here are the lists of AWS assumptions, be it from a cost of compute, the usage of databases, storage, and networking. And again, if you're moving your SharePoint onto AWS, here are some of the assumptions made as well. In this case, for SharePoint Server 2016. If you want to find out more about the TCO, right, you can always take a look at the FAQs, which list the most commonly asked questions about this tool. Most importantly, if you disagree with the assumptions made, you can modify them in this section, like, for example, the cost of hardware, storage, networking, licensing costs, and so forth. So that this calculation, this comparison, reflects your reality. This report can also be downloaded, and all you need to do is to fill in some of your personal information, and it will be emailed to you. Now, I'm going to show you some of the differences between the basic and the advanced options for this tool. By changing the selection from basic to advanced, you notice that there are additional fields that appear under the server section, like, for example, the percentage of the VM usage, what are you optimizing by, is it RAM, CPU, or storage I/O, and the kind of virtualization host you're using an on-premises environment. And under storage, you can define how much of the storage is infrequently accessed, the kind of maximum IOPS expected to be used by application, and amount of data that's going to be backed up each month. So you can have a far more comprehensive look at your usage. We also include the network costs option as well as the IT labor cost as well. This rounds up a much more complete TCO calculation comparison between AWS versus your on-premises environment. AWS wants to provide the right resources to support your success. So whether you are new or continuing to adopt our services and applications as your business solutions, we want to help you do amazing things with AWS. AWS support is there to provide you a unique combination of tools and expertise based on your current or future planned cases. With AWS, customers can plan, deploy, and optimize with confidence. If they need the support, AWS provides the tools and resources to guide them. If there's a user who would like proactive guidance, there are technical account managers or TAMs that are designated as their primary point of contact. The TAM can provide guidance, architectural review, and continuous ongoing communications to keep the user informed and prepared as they plan, deploy, and optimize their solutions. Your TAM is your advocate, your dedicated voice within AWS. For users who want to make sure they follow best practices to increase performance and fault tolerance in the AWS environment, there is AWS Trusted Advisor. AWS Trusted Advisor is like a customized cloud expert, but actually is an online resource that checks for opportunities
to reduce monthly expenditures and increase productivity. If there is ever a need for account assistance, the support concierge is a billing and account expert who will provide quick and efficient analysis on the issue, freeing up the user's time to run their business. The concierge addresses all non-technical billing and account level inquiries. At AWS, you can plan, deploy, and optimize with confidence. To support you, there have been specific support plans developed. Let's take a look at basic support. Documentation, white papers, and support forums. Access to 6 core trusted advisor checks. Access to personal health dashboard. Next, we have developer support. The plan offers resources for customers testing or doing early development on AWS, and any customer who wants access to guidance and technical support are exploring how to quickly put AWS to work. Use AWS for non-production workload or applications. For customers having production workload on AWS, we recommend using business support as a minimum. The plan offers resources for customers running production workloads on AWS, and any customer who run one or more applications in production environment, have multiple services activated, or use key services extensively, depend on their business solutions to be available, scalable, and secure. Lastly, Enterprise Support Plan. The Enterprise Support Plan offers resources for customers running business and mission-critical workloads on AWS. And any customers who want to focus on proactive management to increase efficiency and availability, build and operate workloads following AWS best practices, use AWS expertise to support. For more information and to compare the AWS support plans, go to the URL for more details. While the number and types of services offered by AWS have increased dramatically, our philosophy on pricing has not changed. At the end of each month, you pay only for what you use, and you can start or stop using a product at any time. No long-term contracts are required. Pricing information for each service on our website is available at amazon.com/pricing. Our strategy of pricing each service independently gives you tremendous flexibility to choose the services you need for each project and to pay only for what you use. As stated earlier, the TCO calculator is there to help you estimate cost savings when using AWS. Detailed reports are available for comparing the cost of running your workload on AWS versus on-premises. You can also modify assumptions used to best fit your business environment. The support plans visited today were Basic, Developer, Business, and Enterprise Support Plan. As discussed, all support plans provide 24/7 access to customer service, AWS documentation, white papers, and support forums, access to 6 core trusted advisor checks, and access to personal health dashboard. For additional technical support and support resources, we provide additional plans to fit your unique business needs. We have come to the end of Module 5. Test your knowledge with the following questions. Wrapping up today's course, we will look at what's next for you. The slide shows the current instructor-led training in the AWS Training and Certification Catalog. Classes are role-based and designed to be progressive as individuals gain deeper experience working with AWS services. The AWS Technical Essentials is our one-day foundational training on AWS services. Architecting on AWS is a 3-day course that teaches solutions architects to design and use AWS services for common IT applications. Developing on AWS is a 3-day course to help individuals design and build secure, reliable individuals operate highly available and scalable infrastructure on the AWS platform. Advanced Architecting on AWS is a 3-day course that covers building more complex solutions which incorporate data services, infrastructure configuration, management, and security on AWS. DevOps Engineering on AWS is a 3-day advanced level course that demonstrates how to use the most common DevOps patterns to develop, deploy, and maintain applications on AWS. Security Operations on AWS is a 3-day advanced level course that demonstrates how to efficiently use AWS security services to stay secure and compliant. Migrating to AWS is a 2-day ILT that demonstrates cloud migration strategies and dives into our recommended 5-phase plan for migrating existing workloads to the AWS Cloud. Big Data on AWS is a 3-day specialty course that introduces you to cloud-based big data solutions and Amazon Elastic MapReduce, or EMR, the AWS Big Data platform. Data Warehousing on AWS is a 3-day specialty course designed to teach you how to design a cloud-based data warehousing solution using Amazon Redshift. AWS certifications validate technical skills and knowledge necessary for designing, deploying, and operating solutions on the AWS platform. Earning certifications helps you gain credibility for proven experience working with AWS and contributes to your organization's proficiency with AWS-based applications. If you refer to the various training courses mentioned previously, those courses will assist you in your certification exam preparation. Why AWS certified? To the individual, being certified helps validate their expertise on the AWS Cloud, while for employers, it helps identify individuals with the relevant cloud skill set and also help accelerate their journey to the cloud. Beyond attending training classes, there are many paid and complementary resources to aid you in your certification exam preparations. Begin your journey using the URL given in the next slide, which is www.aws.training. Please go to amazon.qwiklabs.com. Once you're on the amazon.qwiklabs.com login page, please click on Join to create a new account. After creating an account, please click on Sign In and log into Qwiklabs using your login credentials. After logging into Qwiklabs, please click on the menu option and then you can click on Catalog. You will find a set of quests or labs to choose from. A quest contains a series of labs based on technologies or services. Some quests even help prepare you for certification. You can alternatively choose individual labs by clicking on Labs. Under Labs, you will find labs with a title, the level of complexity, and the time required to complete the lab. You will also find the cost of each lab. As you can see,
There are some labs that are free. You can search for a lab on any AWS service available by using the search options. Search for Amazon S3, and you'll find that there are a few labs on Amazon S3, one of which is a free lab. Please start by reading the lab overview to make sure you are interested to proceed. If you would like to proceed, please click on Start Lab. Once a lab has been started, you can follow the remaining instructions. To log into the Management Console, click on Open Console. On the Management Console, you can verify your login and the region of the lab. Please switch back to the Qwiklabs console to follow the remaining lab instructions. The lab starts with a list of topics covered. You start by creating a bucket, then upload an object. Make sure the right permissions are configured, and finally, enable versioning. First task is to create a bucket. Please follow the instructions on Qwiklabs. On the Management Console, search for S3. You can then click on Create Bucket and enter a unique bucket name, such as lab-your name. If the bucket name is not available, please use additional characters for the bucket name. After you follow the remaining steps in the lab guide, you should be able to create a bucket in Task 2. You would upload an object, and then you would make the object public. After you complete the lab, please sign out from the Management Console, and on the Qwiklabs screen, click on End Lab. Thank you for watching. This is the end of the Qwiklabs demo. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. To recap, you can attend our AWS Qualified Instructor-led classes to learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Use practice exams to help you prepare for and validate your technical expertise with AWS certification. If you have watched all 5 modules, you will receive a certificate of attendance. Please look out for it after 1 week. We hope you found the conference interesting, and please take a moment to complete the feedback form. Let us know what you thought of today's event and how we can improve the event experience for you in the future.